Firstly, thank you, Florina. And secondly, thank you all for staying here so long. It's like the second day, end of the conference, and last talk. So, okay, over here, the presentation slide says Android Hamla. So, before I begin with my topic of pen testing Android applications, I would just like to give an definition explanation of what Hamla means. So, Hamla is a Hindi word for attack. So what we are going to see is the techniques that are made used to attack the Android applications. Not only will I be talking about the Android applications, but some of the default applications like settings, or let's say for example certain libraries of Android, right? So which are vulnerable. Well, actually they are coded nicely and all etc things, but then certain of the other vulnerabilities does arrive. Also I'll be talking about, even though there are vulnerabilities, you still need to pay certain respect to the developers. So I'll just begin. So I'll formally introduce myself. I'm Sneha Rajguru. I work as a security consultant slash research slash pen tester slash trainer for Payato Technologies. Payato Technologies is an Indian cybersecurity boutique where we usually perform penetration testing, give security consultancy, then we perform IoT trainings, etc. I'm also associated with few of the non-profit organizations which focus on providing cybersecurity services and awareness among people. That's called NULL. So NULL is an open source community of security experts, security researchers, or maybe those who are interested into security. So we have got almost 9 chapters, one in Singapore and Amsterdam, rest all in India. We also organize a security conference, yearly security conference that's called NullCon. CFP is open till 30th November. So if you guys have committed any sins as in the security sins, okay? So please submit your CFPs, and if you are interested into breezer, breach and beach, Goa is the place for you. So, and next, we also have one more hardware conference that's called hardware.io. This was the first year we launched this conference, and this conference focuses only on hardware hacking, right? So it happens in The Hague, Netherlands, and it will happen now next year. So that's about me. Yes, also, I write CTF challenges for HackIM. We'll be soon launching the CTF for NullCon. So the price is like, if you win the CTF, you get free tickets to NullCon and paid expenses, all. And from since childhood, I'm planning, I try to play guitar, but no use. Anyways, so a quick introduction of the agenda. What we'll be talking about is roundabout what Android operating system is. Then we'll be talking about the internals and the security module of Android. Later on, we'll be talking about how do you set up a penetration testing environment. Then the arsenal. Actually, what you need for your attack to perform. App analysis, how do you actually perform the app analysis? And obviously, respect to the developers. Even if you don't want to, you have to. So a few questions, like how many of you are Android users? Awesome. Android developers? Awesome. Okay, few. Don't kill me. All right. And how many of you have already pen tested Android applications and found out vulnerabilities and reported and earned bounties? Cool. Great. So for the starters, so Android operating system derived from Linux. It says that yes, it has been derived from Unix, but it's not a Linux operating system. So Android has various flavors of kernel. So the earlier versions of Android before Ice Cream Sandwich operating system of Android, it worked on Linux kernel 2.6. Now those who know about Linux kernel 2.6 XXX version, it was a vulnerable Linux operating system, right? So at that moment itself, Android was vulnerable with that particular kernel it had. Next, it came on to Linux kernel 3.xxx for the later versions from Android Ice Cream Sandwich operating system. Basic architecture, it runs on Dalvik, okay? Converts your bytecodes to dex codes and then converts it to an APK and then runs, and then what it is like, what you get is the APK, your application. So basically your Dalvik VM runs the executables, converts the DEX to APKs, and renders you a nice looking application with nice GUI and various other vulnerabilities. Well, vulnerabilities is what you need to find out. So what does this particular APK, your Android application, contains? So basically your Android application contains uh, zipped resources of all your class files, class sources, manifest file, keys, certificate keys, etc. And the most important, Android manifest.xml. Now that's a file that provides you complete information of all the permissions, the components, the intents, or the services that your app is going to render. Is it going to interact with another application? Is it going to go down to your kernel system, file system? Is it going to talk about it or not? So talking about the OS itself, Android has got almost 6 main partitions. Like you have boot, you have recovery, you have cache, you have data, you have miscellaneous, right? So talking about all these partitions, it's very important for your Android OS to have these partitions. Now, firstly, if you want to root your device, or okay, how many of you have rooted phones? That's great. So for rooting or flashing your devices, these are the partitions that you should keep in mind. Now let's say, for example, if you screw up with miscellaneous partition, right? If you, so this particular partition, before I say this particular partition, the miscellaneous one, contains the configurations of your on-off switch, your USB configurations, and various other settings. So if in case you screw up with this particular partition, well then you can use your Android device to, let's say, shoo away the stray dogs or something. So it's just useless if anything wrong happens with these partitions. So security module, talking about, as we know, Android, Linux based, has got two sorts of security models. I mean, I would like distinguish it according to, let's say, a Linux based security module and the Android's itself security module. So considering that it's been derived from Linux, it uses the user-based permission module. That means user A is not able to access user B's resources. When user B is executing, will not be able to hamper or come in between user A's resources. So both are happy, both of them have their own shares, and both are working fine. So that is the basic idea of Android, the Linux permission module. Again, any and every application that runs on your Android has got a different user. You can just check that by help of Android debug bridge or other commands. We'll see that. So again, new process, new user, does not interfere with your ongoing processes, resources, so everything works fine. The sandboxing sort of thing. Zygote, the main core of your Android operating system, this particular daemon is responsible for launching each and every process, assigning each and every process a PID, I mean separating and allocating proper memory, resources, blah blah blah, etc. All things. So Zygote is again the main factor of your operating system. So basically each application has its own instance, own memory, own user ID. So the best part of Android is no other application will come and interfere with you. Next, I would also want to talk about two things, that is called ASLR, right? And then we have PIE, so position independent executions, executables, and address space randomization layout. So these are the security techniques that have been picked up from Linux operating system, and your Android makes use of it. The only reason is to avoid vulnerabilities like buffer overflows, or you also have, you know, format string protection layer in Android operating system. So now all these three things, like your ASLR, your sandboxing, your PIE, it actually tries to make your Android device or the Android operating system, the current running Android operating system, more secure to any other attacks such as buffer overflows or any other overflow attacks. Next, special permissions have been implemented. Android, though open source, it does not allow access to root, right? So it has got its read-only permission module for the root. And that is the reason why we need to go down to certain tools like Odin for Samsung or other tools to, just click, go, and okay, we got the root, we got the access, we rewrote the permission files of Android. So before I go ahead with learning or setting up the, okay, I just skipped something. So what I skipped was basically I talked about Linux based Android operating protections. I didn't talk about Android's itself protections. So how many of you use the device manager functionality of Android phone? That's actually a real cool feature of Android. Basically, if you just sync your phone, and if you lose your phone, just Google out where your phone is, erase your data, encrypt your data. Okay, encryption again. I would also want to talk about device encryption. So it is better if you encrypt your phone, but again, for breaking your phone or taking out the data from your phone after it's been rooted, your even your if you have encrypted or you have long passwords, doesn't matter. In fact, the next vulnerability which we will talk about, that vulnerability itself shows that it's literally useless even if your phone is encrypted. So this particular vulnerability was reported for Android operating systems, iOS, ICS, that is ice cream sandwich basically, and it started from 4.0 till 4.4. Rest of the versions, that is exceeding 4.4 X, are not vulnerable. So the vulnerability says remove device locks from Android. Now what happens is, Android, such a wonderful operating system, correct? It has got so many security features, so many security locks. Let's say for example, we have pin, we have password gestures, the numerical passwords, face recognition, voice recognition, etc., blah blah blah. What this particular vulnerability did is basically your Android applications settings file had a code, okay, that is com.android.settings.chooseLock generic class. Now this particular library was so well coded actually, that it actually gave the apps, the users of the app. Now every app has a user. Let's say if you're running a photo app, you might be having username as u100 blah 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 xxx. Okay, what this particular finely coded library did was it gave the users permission to change the locks. It literally gave the permission. So if I overwrite this particular file with any rogue application, well, not a rogue application, I would say, any finely crafted application, I would say, who could overwrite this file, could actually remove the locks of your Android device. It didn't matter whether your Android device was encrypted, there's no lock, there's no protection, doesn't matter. I still can, because of this vulnerability, I can just go down to your phone, take out your data, and then it's done. The game is done. So the talk for today, I mean, what I will be talking about is how do you set up your complete environment to find out such vulnerabilities. So mostly I'll be talking of few of the tools that you really need to find out the vulnerabilities or to make your work easier, and how do you manually also perform it just by going down to the terminal and digging like the expert hackers and stuff. So it's a choice that you have. So you can either choose a rooted phone, you can choose a virtual machine, or you can choose an emulator. Frankly speaking, emulator sucks. So if you have a Genymotion or some sort of paid version of Android emulators, Well, okay, it will be good, but then it's better to have a rooted device to get the actual results. And you know, working on a rooted phone is real cool. So few of the things that I would want like you to take in mind when you set up a penetration testing lab is like, um, your phone firstly should be rooted. Try to use a physical device rather than emulators and all. Obviously Android SDK also comes up with its own emulator, but again there are limitations on it. You may install CDR substrate. You may install, if you need, you may install it, else it's all right, it's okay. Jay Freeman, he's a great guy. He keeps on writing such tools for us. So still will pay some respect. And if you need, why do we need CDR substrate? Substrate is what I'll let you know once we proceed ahead with our environment setup and tools usage. Next, install any proxy app. Now the reason why I'm asking you to install a proxy app is because if you want to find out what sort of data traffic your application is sending across to its server, or maybe to a third party server, you never know, right? So that is the reason, to find out what sort of traffic is going from your device, you should have a proxy just to intercept. Now there was this one fine application that was known as LED torchlight. Now what this application did was, now considering this application, it's a torchlight application. So it should be using my camera. It should be using the flash of my camera. Let's say for example, okay, allowed the permissions to use photo galleries or etc. Why does this application need to access my contacts, my messages, my call logs? Okay, when I decompiled this particular application, there was a code which said that all these permissions are also there. These permissions were not being displayed on the Google Play Store, but when you unzip the APK, you find a manifest file, and in that manifest file you have list of all these permissions. Now these are the hidden permissions. I mean, this is a security threat. So this particular application was not only providing you the functionality of a torchlight, but it was also sending your data to some third party server. Okay, so there are various applications just to find out whether the application is working fine or it has some malicious intent activity going on. You can, you know, try these methods, find out the permissions, check what this application is doing, are there any hidden treasures available in the APK. You can make use of, you know, unzipping the application and checking out. So that penetration testing approach you can use. So for this particular approach, I would say it's just a vulnerability analysis thing, not the pen testing. Yeah, one more thing, like there are choices if you want to install bug proxy, fiddler, TCP dump, etc. But all these things are only possible if you have a rooted device. So talking about the Android arsenal, the Hamla arsenal that we need to have. So these are few of the tools. Of these you have APK tool, Android SDK, JD GUI, Smally, Backsmally, Introspy if you want to use, Drowser, Best Tool, again Jar Signer, Burp Suite, etc. etc. So most of them are open source. Half of them are like free version, the community version. We guys being the community people, okay, we'll just stick down to the community. Else, we'll get down to our originality, take a, I wouldn't actually recommend it, but then take a software, attach it to a debugger, remove the key checker, and then use the application. But that's not a good way. So Android SDK, great tool, awesome. So either you can create or you can destroy, or you can destroy what is created. So the normal text over here, which what it says is a software development kit. Now everyone knows about Android SDK. It has got various other tools like let's say a platform, Android emulators, pre-created emulators, certain system images and all, etc. So now let's say for example, if you want to test an application for your Android TV, okay, so you can go down to this particular SDK, hop down to the Android AVD, create like download the system image, everything's free, open source. download the system image for your Android TV, install your application within that particular created emulator, and go ahead with your research. So, but considering the pen testing environment, the most important things that we need are ADB, that is Android Debug Shell, AAPT, TDMS, and the emulator. If at all, if you want to stick down to emulator and work, if you do not have much resources, you do not have a rotate phone, this is the best thing. Next is pen testing Arsenal ADB, so Android Debug Shell. One of the most finest tools, most convenient tool for Android pen tester, the ADB, that is Android Debug Shell, a command line find tool, right, that interacts or communicates with your emulator instance or maybe a rooted device. What you need to do is you just need to connect your rooted phone or just connect your ADB, start your ADB, type down ADB devices, you get a list of Android devices whichever are connected. If not, you won't get anything. So these are the few commands that you need to keep in mind. These commands which are mentioned over here are the most used commands for pen testing. So I'll just quickly explain these commands. Is like ADB connect. So ADB connect will try to connect the any sort of Android, let's say, device or an emulator which is connected to your host machine. Okay, it will provide you whether the device has been connected or not. ADB devices will list down all the Android devices that have been connected, be it a physical device or be it an emulator that's running on your machine. So it will nicely give you some 14 character long Android name and the device number. And you just need to type down the 14 character name and ADB device, this particular number, you get a list, and ADB connect to this particular number. Next is ADB install. Again, a very fine utility. If you need to install certain third-party APK on your device, just download that APK and ADB install third-party APK. That's it. So that particular application gets installed on your connected Android device. Next is ADB push. If you need to push some data onto your device, okay, so just type down ADB push and put some files onto your device. Now let's say, for example, if you want to pick up some files from your device, it's ADB pull. So push and pull, normal terms. Great tool. ADB shell, if you need to access the shell of your device, okay. Now there are few things, right? When we talk about ADB shell, okay, we got a shell of our device, that is bin, bash, etc., etc., whichever shell it is using. Now at times, if you have seen, there are various MDM softwares, that is mobile device management softwares. Various companies are starting to implement these MDMs. Anyone who is under MDM or something? Great. I have a question then later. So MDMs claim that they 100% find out. That is what certain blogs write. So they find out whether the device is rooted or not, okay, or jailbroken or not. Now basically what techniques they use is some of the 5 techniques that I would club. Is like they'll go down, they'll try to find shell for your rooted device. If they get a shell, boom, it's a rooted phone. Next, they'll try to find the SU binaries. Okay, even if you disable shell, they'll try to find out SU binaries. Again, if they get SU binaries, again, it's declared that the phone is rooted. Next, they'll try to find out permissions of your file system. If your root has the permission of read write, please remember by default your root has a permission of read only mode. If the root has a read write permission, it's a rooted device, right? This is what it looks for. Next, fstab. Now fstab is one particular file where let's say your complete Android, data has been written on it. So if there are any changes in the default applications, like let's say for example, the ringtone application. If I overwrite my ringtone application, that's going to reflect in my FS tab. So let's say for example, it compares the size of my FS tab. Okay, if the size varies or is it been recently modified, boom, it's a root. Okay, these are the, I wouldn't say the complete steps, but few of the steps that declare whether a phone is rooted or not. This is what MDMs claim, a general technique that they use. There might be various techniques, I still haven't like gone thorough in it, but these four techniques which I have been through, what I can do is I can still fool that particular MDM. Yeah, one more technique what they use is, let's say for example we have rooted phones, we make use of applications such as super user, chainfire, some etc 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 things. So let's say for example we picked up chainfire, it will try to find out such sort of applications, are they present in your file system or not. So that's also a technique which MDM uses to find out. Now we guys being penetration testers, we also need to bar whether this particular MDM is checking our phone or is checking the integrity of our phone or not. Okay, so what we can do is rewrite root system. You already are root, it's very easy for us to rewrite the root system. Temporarily change the location of your SU binaries, MDM again fooled. Change the file size, again fooled. So these are the techniques. An able hacker will definitely be able to fool your MDM device. So when it comes to penetration testing in an corporate environment where they say that, okay, we follow MDM, our application, our devices are secure. These are the things, these are the checks that you also need to perform. That, okay, even if I'm a root, all right, I can still rewrite my file system to a read mode. Obviously, keep a backup of it, like always keep your backdoor ready. Or you can change the location of your binaries, rename the applications, etc. stuff. So this is how also you try to, step into or start into your penetration environment basically. Debugging tools. So this is again a command line utility that comes around. Apart from this, if you want to go more deep, you can make use of various debugging tools available, right? So DDMS, it's basically our Dalvik debug monitor server. This particular tool is going to be so kind, it is going to help us find out the screen, on the screen, the logs, so what we basically do is we go down, we do check our logs, syslogs, logcats, etc. So the best thing is just like DDMS and your Android application device, that's it. So whatever you want to find out, give the options, like you want to get a heap dump of your operating system, how it is performing, what sort of application was running, what it is taking up, right? Next part, very crucial part of your debugging environment, dex2jar. Now basically your Android application APK is in a dex format, right? If you just derive this particular dex format and try to go down into the Smalley code, right? So Smalley code is some sort of like assembly code, I would say. So I'm still learning with the Smalley code, but then it's better to convert it to a readable format, a human readable format, than to go down to a low level language and try to find out things. Sorry, high level language and try to find out things. So dex2jar is a utility that converts your dex files to jar files, right? Next comes JDGUI. JDGUI is a graphical utility, a standalone utility of Java, which converts your jar files to Java class files. The finely built class files where we can actually read, okay, public class method login event. Fine. So that's what your JDGUI is going to give you. Next is Smalley, Backsmalley. If you are way too good with the assembly codes, you understand Smalley language, So Smalley and Backsmalley tools are basically your assembler and disassembler of your Delvic codes. Introspy. I do make use of introspy. It actually eases the job when, let's say for example, you have almost got 12 hours and your client is saying that I need to launch my application and this is the last moment security check and I need to find out whether my application is vulnerable to client side injection, or is it vulnerable to some format strings, or is it vulnerable with some sort of, does it have some sort of dangerous permissions or not, etc. You can make use of introspy. Now there's this one particular slide. It's a little abrupt what I have kept over here because I wanted to discuss few things over here. Like what the slide says is like tool to bypass SSL certificate pinning for most application. To get this, install Cydia Subtrate or Android SSL Trustkill. Now the reason why I implemented this particular slide was various applications. Like I'll name these applications such as Facebook, LinkedIn, etc., etc. Like all these huge applications, everyone, almost everyone uses these particular applications. Now when you go down and penetrate these particular applications, you don't find certain requests. Reason, there's something known as certificate pinning. There's some sort of checks that are going on. So to remove those particular checks, you can either go down on a manual approach, or there are tools available online, open source tool, open source community, such great people. Just download the tools and boom, you just remove the certificate checks or some another checks. So you can include this into your environment setup list. Or the best part is, being a community person, do it manually, do it on your own. Go down to your terminal, go down to your shell and check the codes, attach it to a debugger, find out which HTTP default builder class, developers, right? HTTP default builder class. It's a class which defines basically certificate and key stores, etc. This is just a vague explanation of it, but this particular class method, it helps you implement the certificates. Burp Suite, best tool ever, be it mobile, be it web application. You may make use of it. I make use of the free version. Okay, that's good enough. So this is a tool that you can make use of. You can also use Charles Proxy, maybe Fiddler, whichever you're comfortable with. So the only reason why I'm talking about Burp Suite is because if you want to analyze the network traffic of your application or the ongoing traffic of your application, so GUI utility which shows you, okay, this was the host request that went, and along with this request, your systems, your devices UUID went, or your carrier information went, or let's say for example, the app also sent information regarding your phone number, your location, etc., etc. So the reason why you should be having some let's say interceptor is because you can find out what sort of information is your application actually sending to the server, whether it's sending to the server or it's sending to a third party server. The transport layer security, is it using any sort of transport layer security, like is it going on HTTP, or is it going on HTTPS? So you can find out whether your application is either going down or sending data in clear text or in an encrypted format basically. So that's a tool that is again suggested if you want to, like, while creating the pen testing environment. Drozer, a wonderful tool. Again, you can make use of the community edition. It's good enough. But if you really want to go down to the ground level thing and exploit it, you can make use of the paid version. So the free utility of this particular version will allow you to find out the attack surfaces, to perform certain injections, create your own agent, add your own permissions to the application, the APK file, manifest file, rebuild the application, rebuild the permission files and send it ahead. So you can make use of it. If not, Manual ways are always there. Go down to your device, go down to the input box and type down certain injections, etc. stuff. Now, one more cool vulnerability. While the reason why I have included such abrupt vulnerabilities list is because when they say that we are penetration testing certain applications, right? You also need to go down to a level where your device, your operating system, is it also vulnerable to this particular certain vulnerabilities or not? What sort of applications are communicating with your settings, let's say default device applications? Why does it need to communicate with your default built-in device applications? Or let's say even if it is communicating, what sort of data is being transferred with your default Android applications? So this one was cool vulnerability which was launched, which was exploited actually. So the vulnerability says that is vulnerable to Android 5.x. I forgot to mention 5.1. Later on, it's all cool. So lock screen bypass. So how many of you have heard about this vulnerability? Cool. So what this vulnerability did was, you have a lock screen. Like I said earlier, Android provides various like security mechanisms like PIN, passwords, face recognition, gestures, etc. stuff. It also provided this functionality, that is the password functionality, the lock screen functionality. Now what this particular vulnerability did was, what this particular vulnerability did was, if you type down your password, your lock screen password, copy that particular lock screen password and paste it multiple times, like create a huge string of, let's say for example, 20 asterisk signs or question mark signs and try to send it. Before doing that, when you send this, try to open your, let's say, just Android has got very nice GUI utility where you can just left swipe, your camera opens, right swipe, your camera opens, or your call opens, or let's say your emergency dialer opens. Just copy paste this particular entire huge string and try to run it. What happens is the application that is trying to access your camera crashes, and when it crashes it is actually trying to execute the camera screen, and when it crashes the entire process, and when it crashes the entire process you already have access to the main screen. That means you have already bypassed the lock. Okay, so not only the third party applications that you install from Google Store or from some external website, but also your own device applications are quite vulnerable, and they are actually quite funny. The earlier vulnerability, who would understand, like it's a system settings app, the nice setting symbol, gray color symbol, that application is vulnerable. That used to provide access, grant user to change the lock screen. Strange. So make use of Android the most. Open source operating system, fuzz it. Now talking about the APK. So we already had discussed about some of the tools and the setup that was needed. Now let's understand the APK structure. Okay, so APK structure, how will be defined is like we'll go down to certain components of what your Android devices are made, Android applications are made up of. Okay, and the reason why these over here are mentioned here, these are like activities, intents, broadcast receivers, content providers, and intent filters and Android manifest file. Now there are various others, but comparatively, when you try to evaluate from a point of security perspective, or when you try to find out vulnerabilities, usually these are the few points that you can make use to find out the crucial information from your application. So the first is like it says activity. So represents the UI of your application basically. So let's say for example we have an application that's called login application, which just has got nice UI, nice some floral designs and a username and password field and a submit button. Okay, this is where your activity comes into picture. This is what your activity defines. So represents a single screen with a user interface, right? Next, what we have is services. Now, what sort of activity? Like media player. Okay, so we have a cool media player on Android phone. Even if you run a music, you close it, your service still runs at the background. Okay, so services define whether your application should be running in background or not. Content providers. So these, I would say that content provider is such good, such genuine thing that it takes data from your application and with the permission goes down to another application and gives the data. Not only that, if the content providers, right, so are also combined with certain explicit intents and some data, it can also transfer data from your application to another applications, right? So manages a shared set of applications. I have mentioned example as access Google contacts. Okay, so let's say for example when you're trying to sync your application, sync your calendar. Okay, so what happens is when you go down to your calendar, this is an example. So if you go down to your calendar, sync it, what it is going to do is it is going to shoot its services, it is going to browse through its permission, it is going to go down to the various other applications which it is supposed to take data from. Okay, not only this, but your, let's say Facebook has recently launched the new feature which says that if you have a new photo on your camera roll, okay, and if you open Facebook, you get you have a new picture uploaded on Facebook or not. So basically Facebook is accessing your photo gallery, checking it whether it has got any new updates on it or not, like any new photos or something. So this is what they are sharing information, sharing data with each application. Now earlier when I talked about the LED torch light, it is still on. People are still downloading that application. So what this application did was it went down to your Google contacts. It created a list of all the contacts and it used to send. So this is where your content providers were working, were taking data from one application, sharing it to the another application, blah, 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 and vice versa. So content providers, suppose I have an example of it. So we'll check for that particular content providers how, like, and always remember it's also a crucial part. When you browse through an Android application permission file, you should go down to this particular file, check whether what sort of content providers are there or not. Broadcast receivers. Normal example, if I would say my battery is low by 15% or 3%, that's going to continuously broadcast a message. So let's say for example, if you have some new notification, okay, so that is also going to get reflected in the notification area. That's a broadcast that is going to happen. So you find a nicely someone tweeted a photo, you get a nice bird on your left side of the screen or something, works here. Intent filters, again a crucial part where you should keep an eye on these. Always remember, do not make use of explicit intents. I mean, explicit intents are not so good advised. Even if you just go down to code.developers.android.com, a nice list of coding standards, and even in those standards it's mentioned. The only reason it is mentioned is if it's an explicit intent, it can be called out from any other side, like any other application externally, and you can make use of it. So intent filter, a message object to request access data from one application to another application. And the thing is that even this intent filters, like, so if it's implicitly defined, good enough, but explicitly defined, okay, I can still provoke one particular activity even without entering or even without authenticating on the device. Just from outside I can provoke an activity. Most important part, Android manifest file. If you read this file thoroughly, I would say half of your pen testing work is done, because over here you'll find nice treasure of what sort of permissions they are. Is the application in a debuggable mode or not? If it's in a debuggable mode, well, that's another great thing. So you get to know about all the information of the application from this one particular file. The app structure. So basically, you pick up an APK, rename that APK. So let's say for example, I have defcamp.apk. I'll just rename it to defcamp.zip. Okay, it's a compressed file. Extract this compressed file, and this is what you get. So you get a meta-inf. Okay, now resources, your android.xml file, classes.dex file, etc. Now all these files contains your Android manifest contains your permissions, classes.dex contains your Java source code into the dex format basically. Next it contains your key stores, your certificate information. All right. So yeah, signatures and app resources basically. So again, just few points you do not forget, and remember the importance of Android manifest.xml. It's like provides information about the app to the system, the entire permission, defines app permissions, app components, which we saw. Now there's one more way. Now earlier we saw a tool that was APK tool. So APK tool is again an utility which does the unzipping work or extraction of APK components for us. So either you can make use of like you can use it manually, go down to APK, rename it, extract it, or you can just use APK tool and your APK name. Obviously there are certain sub components or sub options. So your sub option goes as like APK tool space D space your APK name, whichever you want to decompile. Okay, that is also going to render you the same thing. Now this pretty image over here is of Android manifest.xml. I have a development app that is called Catch. It's available. It's an open source app. It's available on Play Store also. Uh, if you want to start pen testing Android application, I would suggest this is the best app where you can, try your hands on multiple vulnerabilities like command injections. Let's say, for example, exploiting the components, activities, etc. So the APK package is com.freebananas.notes. So what this particular application is all about, a simple application, a very lightweight application. It has got a login screen, and when you enter a correct password, like after providing the authentication, blah blah things, you get a notepad, you can write down your notes and store it. And when you exit the application and when you re-enter it, again it will ask for the authentication. So that is this application. Now, is it visible? Okay. So, like I said about the activities. Now, this particular application, the manifest file over here, it showed an activity, an explicit activity which could invoke the notes basically. Notes as in, even if you do not provide your login information, the note area, the notepad area gets extracted, gets opened. So one note that I would like to say is like activities, services, receivers, well, they should not be exported, or else you can bypass those easily. So all these activities and services over mentioned over here, this particular activity which invokes the note editor, okay, it's an exported activity. Now by default, I'm not pretty sure, but I just got confused. But by default, your Android, till SDK 16, your every manifest file, okay, was by default export enabled, was by default debuggable. But after 70, the values changed. The values changed to your export became false, your debuggable became false, etc. So again, like I said, manifest file, please keep a good eye on manifest file. Most of the work is solved with manifest file. So it's like you find out various good vulnerability tricks from your manifest file. So what I have highlighted over here is receiver Android exported equals to true. My activities, my components, my services, etc. are all exported. I can easily, without entering into the application, just go down to my shell, ADB shell, and just pick up this particular activity, invoke it, and then use it. IoT, I'll just go a little off the track and I'll talk. Now the market is turning towards IoT. Every other thing, okay, they are trying to launch smart apps and smart devices, etc. Now all these smart things are having some not so smart applications, the apps. I mean, come on, things are changing. You do not carry your laptop everywhere and, type down your, like, enter your network and say, I want to turn on my refrigerator or microwave, or I want to start the air condition. You do not use your laptops and connect to a network and do these things. Just a small application app, go down to the app, switch it on, turn on AC, turn off AC, etc., etc., etc. So the vulnerability with this particular app was basically, what had happened was, this app used to send UDP commands to its server. UDP commands, firstly, it's sending. Secondly, the best part, when I decoded the class sources, right? So when I converted the classes.dex to Java class files, I found out that there was one nice line which said AES 256 function key, and there was a long key. It had a hard coded key on it. Now there are various applications. Now let's say, for example, I have now got that one particular hard coded key. There are millions of such plugs. Cancun is a Chinese plug basically. I actually forgot the company's name, but yes, you can find the research paper on payato.com/research/Cancun. Okay, so this is a particular Chinese plug. There were two vulnerabilities in it. Firstly, it used to run an HTTP server, which has got no I mean, like, I don't know why it was running also. There were no requests for it. Secondly, it had an AES built-in key, hard-coded key. I mean, now I have this one particular hard-coded key. Any device it may be. Let's say, for example, if it's someone's refrigerator key, okay, so this particular plug, if I have attached a refrigerator, I just need to go down to the local network of this particular environment, pass on my command, okay, and encrypt it with a 256-bit key. The AES key, I already have the key that's hard coded, and boom, I can do anything. I can turn it on, I can turn it off, etc. stuff. So considering the severity, if let's say, for example, that plug was plugged into some IoT or medical device, you can still go down, you can exploit it, and it can cost a life. So there are applications. The reason why we do perform pen testing is because we need to find out such sort of activities where developers hard code the stuff like keys, the URLs. So that was the vulnerability with it. So this is how you can find out. So go down to your APK, decompile the APK, find out the class files. Okay, so yeah, so this is one APK that I have used. So unzip the APK dot classes.dex files. Basically, if you want to find out what sort of source code it is compiling, open the Smalley codes. So uh, so this is just a sample Smalley file of this particular application. All gibberish data. Can't understand. Forget. Okay. So go down to the Smalley file. If you want to work with Smalley codes, best way is to attach a debugger to it, execute each and every function, try to see which function gets invoked and which Smalley codes get highlighted at that particular point. It's similar to what you do for reverse engineering of malwares. So this is basically a reverse engineering thing of Android applications. So I had this particular file, like screenshots ready written. because it actually happens with me whenever I give a presentation. My virtual machine crashes or something bad happens with me, so it's a jinx thing with me. So to be on a safer side, I already took out screenshots. I wrote down each and every command. Okay, so this is the standard technique that you follow basically to find out or to decompile your application, get down to the smally codes, go down to your binary things, find out the vulnerabilities and get back. Or after the or, if you can see the APK tool, just make use of APK tool and your work is done. So it's just like APK tool space D option hyphen if you want to debug hyphen D your APK name, and that's it. Now, earlier in the earlier slide I talked about something known as certificate pinning. So certificate pinning is basically when your application performs certain security checks based on certificates. Now, one more thing that I would like to say is certificate pinning, they say it's a security measure. Again, it can be bypassed easily. I mean, you guys must have heard about the recent vulnerability. Symantec guys, they issued a fake Google certificate, just recent thing. I mean, that's crucial part, right? So you can just go down to Symantec and say, "Hi, I'm from Google. I need a new certificate," or just ask Jason to go and social engineer those people and get a nice certificate for you and put it in your fake application, and then boom, go ahead. You have all the data. You have compromised one part. So yes, certificates a good thing to implement, but remember it can be bypassed. So the techniques what we pen testers do is, now let's say for example there's a fine app of DefCamp, right? DefCamp.apk. I need to sniff out what sort of data, what sort of network data it is transferring. Is it transferring my speaker's ID? Is it transferring my speaker notes or not? Is it transferring to DEFCON? Is it transferring to Black Hat, some third party servers or not? So if I need to find out, I'll have to attach a proxy to this particular device of mine where I'm running this application. Okay, when I attach my proxy, if I do not get requests, I can consider a point where this particular application is making use of certificates or there's certificate pinning in it. Or what I can do is go down to the code. You already have the entire manifest file, you have the classes files. Try to find out such tweaks like HTTP default builder class, HTTP client builder class, etc. Try to find out all these tweaks. If you get this, try to go down to the source code, try to find out are there key stores being used, is it being matched, something like that. So let's say for example our application makes use of certificate pinning. There are two ways what we can do is, like the earlier slide said, make use of SSL trust kill, just a button and you are gone. Or if you want to reverse engineer, take an authenticated approach, you can go down manually, attach a debugger, go down to your class files, find out the pinning class and remove it. So there's this approach which I have mentioned over here. So these are my smally codes of this particular application. In the next slide, I already have found out with use of debugger. So I use basically IDA Pro. So with the use of debugger, I came to know that this is one particular smally code which is basically trying to invoke my certificate. What this particular code over here is doing is, it is trying to find out, the function says, it is trying to find out if key stores are present, load the application. If key stores are not present, do not load, terminate the application. So basically it is trying to find out the key stores, those key stores which are already binded with my application. So what I did was I just removed this one particular function which matches the key stores. The parent class function says that there should be key stores. Agree, there are key stores with me. The main function which checks says that these key stores should match the key stores present. I just removed this one particular check, recompiled my application, generated a certificate, a key store of my own. So key tool, the Java utility, best utility ever, right? So just make use of key store, generate a certificate, bind this particular certificate with your application. So this is pardon me. So this is a particular technique, like normal, just it hardly takes a minute also to type this command and generate a certificate. And then obviously you have to follow those procedures of like whose name, country name, etc, blah blah blah. Give a passphrase, should not be 6 characters, should be greater than 6 characters, etc 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 stuff. So once you have your key stores with you, just bind those, jar sign your application. Okay, once it's done, you have actually built a new application. Now one thing, while considering this particular scenario, when you pen test an application, when you remove a certificate, please remember it is not the legitimate application which you were checking. Okay, so by removing this, if you go down and say, hey, I got a vulnerability in your application not only transmits on, let's say for example, SSL, but it also transmits my UUID. The user's confidential number is what it is transmitting, and I'll report this vulnerability, you pay me. No, this application is not a legitimate one at the moment. But you can go down to the manufacturer, tell the manufacturer that, okay, this is what is happening and this is what you should not be doing. Okay, because the reason is you have not tested this particular vulnerability on the legitimate one. The keys are changed, the application is changed, the functionality of that application has been changed. So these changes, please keep in mind. But yes, this is a way you can just report it, that okay, I decompiled your application, I found out all these things are there. And you can ask and if the manufacturer is kind enough, you get paid. Like there's this application Sunrise Calendar, okay, that pays. So that paid me. Next is, if you want to zip a line, like let's say for example you have built some code and there are some minute garbage gibberish things left on your application, you can make use of zip a line. So you can include this particular tool as well. Stage fright, I mean, I also had this stage fright thing. That's okay. So the best part of this vulnerability was, till date, any vulnerability in Android that came needed human intervention. But stage fright, cool, just send a video, MMS, and your work is done. So the stage fright, basically what it did was affects your greater than 5.x. All right, what happens over here is this one particular library, that is lib stage fright. The stage fright is its name itself. What it does is, any video, it actually allows media player to play, execute, not play, actually execute any video that comes, that streams around. So if you send a MMS, it is going to load that particular video and execute it. So if you bind some executable codes with your video and you send it to someone, for this particular attack, all you need to know is some executable code and a phone number. So once you have these two things, it's done. The device is exploited. Next is, when you go down now for penetration testing, you need to have some human interventions, right? So human interaction with the application. So let's say for example you type down some data onto your applications, play with the application for some time. Once it is done, go down to the file system onto your device and try to get as much as data as you can. So over here you can make use of the ADB pull command to find out the data. So go down to slash system data application slash and the package name and try to derive data. Usually your package builds 4 static folders you have, that is shared preferences, you have cache, you have files, and you have database, and some string, like some etc etc files you have. So shared preferences. Now the thing is that for pen testing, to find out information from your local device, like from your file system, go down, search for each and every file. Yes, it is true, you have to go down, you have to browse through each and every file. If it is in some binary format, make use of strings command maybe. and try to find out what sort of data has been stored into those applications, right? So at times, the critical informations like in your shared preferences file, you get your username and passwords. You get your data. Now, there was this famous vulnerability with Facebook. Actually, it's not so famous, but what Facebook did was when the Facebook application crashed, it actually wrote the session ID, usernames, and passwords in the log file. I mean, that's crazy. Who writes everything in log file, that too in a clear text? Second thing is like there are certain permissions in Android file, manifest file, if you read through it. So there's one particular permission that is known as read and write to external storage. Who, which application goes down to an external storage and writes down, yeah? And that too, there was this one particular app which I tested for my client. I'm not supposed to name it. So what this app did was very intelligent thing it did. It had this one particular permission, and I don't know, it always pricked me why this permission. I went down to my SD card and I did ls. I found nothing. I did ls hyphen la, and I found out that this particular application was writing to my SD card file in a hidden file format. It was actually writing everything in clear text. But one smart thing what it was doing was it was hiding the file. I mean, so these are the things that you need to keep in mind. So if you find out, okay, there's this permission, it means that there can be something that has been written onto your SD card, or it cannot also be. So that's just a tip that you should keep in mind while performing pen testing. So like this vulnerability, if you just go down to Bugcrowd and report it, I'm sure you will get almost at least $250 something. You'll definitely get it. SQLite database, yeah, like if there are stuffs written in clear text, Twitter had this vulnerability. Twitter, what it did was whatever tweets you write, it's all in clear text. Bad. Bad stuff actually. Your various other online messaging applications, it literally writes your phone number, your name if it's mentioned, the text message, and to the person whom you have sent it, at what time you have sent it, etc. stuff in clear text into its database. I mean, if I get access to your device, and let's say, for example, for my convenience, it's a rooted device. I mean, I can just pull out all the data from this particular applications, and I can, I can just like bother you by, hey, you wrote this message to this person. Or I can just blackmail you about, okay, you transferred this much money, okay, he's your boyfriend, she's your girlfriend, blah, blah, blah stuffs. And, I can perform some criminal intent activities, or I can be just a good person. So the thing is that go down to your file systems, try to browse each and every file that your APK creates. I'm pretty much sure some of the other data, some of the other confidential user data will be available. And of course, the developers. I mean, sorry, but seriously, developers, I mean, I know you guys are under quite a lot of pressure to, meet the deadlines, create the application. In a hurry you are, and you just write the code so randomly. Now, I have tested almost 98 applications. Yes, on a precise 98 applications. That includes Android and iOS both. What I found out after analyzing the source code, the Java class file source codes, particularly speaking about this Cancun, it was so easier for me because the source code which that person had written, that person was in so hurry that the person had copied the entire source code, the examples from a Git repository. I just googled one line and I got the entire source code, and I was like, hey, it's the same thing. And he's copying it from W3 schools and Git, where they are teaching you how to write down a code, how to code a Java application file. I mean, that was insane. I couldn't stop laughing for at least an hour, and I was like, wow, cool. And the worst part, AES encryption key was hard coded, man. I mean, insane. So developers, now there are various websites which actually provide you secure coding guidelines. Now, secure coding does not only mean you make use of obfuscation. Okay, obfuscation to a level can also be, we can read it. We can try to find out, map it. Okay. I would also suggest one thing, that do not make use of your own inventions, like do not create your own encryption standards until and unless it has been tested for, let's say, for example, some 10-20 years and no one is able to break it. There are various schools encryption standards provided by Google, Android. You may make use of it. So these are the few examples, 4 of them, which I came across while testing all these applications, and these are the common mistakes that developers do. So it's like world readable. Now, any information that you store on your device, this Android has this one particular permission enabled in the manifest file. Now, any device you write, like any information you write down onto your application, it goes down to your file system, gets written, access the file system, everything is visible. I mean, it's all in. It's not just in read-write mode, but you can modify that also. So sensitive information should not be stored actually. But if in case you have to store it, then please make use of encryption techniques. There are various encryption techniques available. Make use of those encryption techniques. Okay. But of course, it is still vulnerable. So I would never say that there is 100% secure method, 100% secure code. No. Insufficient transport layer. Try to check whether your application has implemented TLS security or not. So TLS security is quite good thing till the time your certificate is not ripped out, or Symantec again becomes such wonderful company which issues you a rogue certificate of Google, Android or Facebook or something, or if you get a certificate. Okay. Never use your own certificate. I would say I would actually suggest make use of the certificate which has been issued by a CA, certified authority of the certificates. Client-side injections. I mean, seriously, you have developed a web UI, nice web UI, but it's not sanitized, it's not filtered. Now, there were these 2 particular vulnerabilities that I came across. One is XSS. It happens on a mobile device. Nice. Next is SQL injection. I mean, what this app was doing was, nicely, there was a login screen, username and password. And if you enter a wrong username, you get a nice message. When you enter username, single quote and a truth value, let's say A equals to A or 1 equals to 1, it gives down list of all the users. The first line says this is a false username, and then there's a nice list of all the users. And seriously, no users input sanitization. First and foremost thing of pen testing or secure coding is never trust your user. I would never trust a user. Lack of binary protection. 50%, more than 50%, I would say 75% of the applications which I have tested, there's no binary protection, no obfuscation used. I mean, come on, Google is providing such nice thing. I mean, like ProGuard, make use of it. Not only ProGuard, there are various others, depends upon you, the developers. Make use of those applications, bind your codes. So there's one line, I prefer this particular website, developers.android.com, best. One thing that I would say is, if you want to break into something, learn that thing first. So if you are clear with what that particular application is, like how it is been built, it becomes much more easier for you to break into it and rip the particular application out. So in my scenario where I came across various such sort of applications, be it Android, be it iOS, I mean, these are the common vulnerabilities or the common flaws that I have found out. Now, OWASP has given us very nice list of top 10 application vulnerabilities. One vulnerability which was so particular, that was session hijacking. I would rather say it was session writing, but hijacking also I could say it. So I had this one particular application which was a social networking application, something similar to LinkedIn, but not LinkedIn. Okay, if it had been LinkedIn, I would have been rich, quite rich. So what this application did was, I created a user. When I checked the requests, I got a username, I got a password, and I got a session ID. Nice 64 character long session ID I got. Okay, I copied this one particular request. Next thing I did was I created another user. Again, I got a nice 64-bit session ID. Next, I logged out from the second user. I entered the first username and password. Very simple. When I was about to log in, I intercepted that request. I just interchanged the session IDs. And obviously, it was not a surprise. I was pretty much sure because there were no checks done. I got the complete profile of the second user which I created. Simple thing, no checking. Still, you're providing me a 64-bit long session ID. I mean, what is the use? If you're not validating your requests at the server side, what is the use of providing such checks? CSRF tokens. Applications at login authentication time should provide you CSRF tokens. It's a good thing to have this particular security measures in your applications. Okay, so these are some of the flaws that I have seen. There are actually various other flaws, if I would say. So top 10 vulnerabilities, please have a read through it and you can, match or try to find out various vulnerabilities of it. So one thing that I would say is like turn off your USB debugging and all stuffs, etc. Be safe. Do not download it from third-party applications. These are for the users. But if you are a pen testers, well, you need not worry about any of these things. Yeah, one thing that you need to worry about is when you analyze an application, make sure you run that particular application in a sandbox mode. If there is any malware attached to it, then obviously we had various like good talk on a malware reverse engineering. You can perform that. You can also check what sort of requests your app is sending and stuff like that. So, yes. So, you have any questions? I can answer those.
Thank you so much for your presentation. It was... Oh, sorry.
Just a quick question. Where do you see the antivirus companies actually doing with the Androids? It's like, I mean, is it really effective with these apps? Antivirus. It's like, I mean, how good is antivirus actually on Android devices?
No good. So they say, yes, it has been written like for antivirus vendors. My point over here is like antivirus vendors. Okay, they just go down, give a checksum, calculate a checksum and provide it to your, scan it. If you have this one particular checksum present, okay, there's a malware present. But what if that malware is so smart that it executes after some time? After some another process. How would you do that? So the antivirus vendors, I would like to tell them, perform or make use of dynamic analysis. Check what sort of APIs are being invoked. So that is what. So.
Any other questions? No? Thank you so much for your presentation.